Welcome to ClickMyProject.com. Today we discuss about a new project. The title is Yearly Prediction of Chronic Kidney Disease using Deep Belief Network. This project based on kidney disease. Let's see the abstract. Yearly detection and characterization are considered to be a critical factor in the management and control of chronic kidney disease. Yearly detection of any disease is very critical factor in the management. Here the same problem also kidney disease. Yearly detection is very critical factor. Chronic kidney disease is detected during the screening of people who are known to be threatened by kidney problems such as those with high blood pressure or diabetes and those with the blood related chronic kidney disease patient. So the yearly prediction is necessary in compacting the disease and to provide a good treatment. See, once kidney disease is affected, the people threatened by some kidney problems such as high blood pressure, diabetes, and blood related kidney disease also. So the yearly prediction is very important and to provide a good treatment also. The study purpose the use of deep learning techniques for CKD such as convolutional neural model to classify the kidney disease. Here we apply the deep learning algorithm, convolutional neural network algorithm to classify the kidney disease. The proposed model achieves better performance comparing with the existing model with accuracy 99.52. So the proposed model present proper predictor and a classifier for CKD. We apply a CNN algorithm, it compare with the existing model, it will get a high accuracy 99.52% of a CNN model achieves better performance and compare with the existing system with accuracy 99.52%. The proposed model presents proper prediction and classify the chronic disease also. Let's see the flow diagram. First start and select database. We select the database in a UC respiratory and then data set name is kidney data set. Data pre-processing convert imbalanced data set into a balanced data set is a process of data pre-processing. First to find the missing values, after that label encoder way we use label encoder, the string column convert string variable convert into integer variable. After that model splitting model after that model selection, here we split the data set 80-20 ratio. After that algorithm we apply CNN convolutional neural network algorithm, and then result generation like accuracy, precision, recall, F1 score, root mean square error, and mean absolute error, and finally classify the kidney disease, yes or no. The result is CKD, chronic kidney disease, or non-chronic kidney disease. Let's see the screenshot. So first read the data set, ID, age, blood pressure. These are RBC red blood cells. So these are all the data set. To read the data sets, so these are the classification, CKD and no CKD. After the data pre-processing we check the first null values in the data set. So here see the age 391, BP 388, AG 353. So null values are there. So here we apply categorical column means we split the numerical and the categorical data. Categorical data is say yes or no, normal or abnormal. So these are the categorical data. So we can change the values after we fill the null values. So here check all our no null values are there. Age, BPSG. After that model is here. We apply sequential model. So sequential model, they are the layers, dense layer, dropout layer. So this is the layer. So totally we apply 50 epochs. The first epoch's loss is 69, accuracy is 61, value accuracy is 59. After each and every accuracy, see each and each and every epoch the accuracy will be increased. And finally we can get the overall accuracy is 98.44, loss is 4.0, loss is 0.04, value loss is 0.03, value accuracy is 0.984. So totally trained accuracy is 99.1 and the test accuracy is 98.8. So these are the overall these are the graph, number of epochs, 50 epochs, loss and accuracy. Here loss, value loss, accuracy, value accuracy. So these are the graph thing. Precision, recall, F1 score and support. So 0 and 1, total 80 images, 52 is 0, 28 is 1. Here precision value 1.00, recall 98, F1 score 99. So 1 also 0.97, 1 and 0.98. Here the confusion matrix, there is only one error, there is only one will wrong prediction after all. So this is root mean square error, value 0.11, and then MEE, mean absolute error is 0.12.